In this video, we're going to do the classic carbon pillar experiment. But as always, this experiment produces toxic gases and deals with corrosive chemicals. Wear gloves and do this experiment outside or in a fume hood. So in a 50 milliliter beaker, I've got about 30 milliliters of drain cleaner grade sulfuric acid, which is around 95% concentration. It was left over from a previous experiment and I wanted to use it for something. So here I'm dumping in just a thing full of your typical granulated sugar, which is sucrose. It's got 12 carbons, 22 hydrogens, and 11 oxygens. And what we're doing is we're using the sulfuric acid to dehydrate the water that's contained in the sugar, which gives, if you put the H22 and 11 oxygens together, you get 11 things of H2O, which is water. So as it's dehydrating the sugar, all that's going to be left of it is carbon, which, as you can see, is black as it turns the white granulated sugar to this black color as the sulfuric acid dehydrates it. Now, normally when you perform this experiment, you would take a stir rod and you would stir the granulated sugar in with the sulfuric acid to make it a little more mixed in there. I just poured it in here, but the effect will still be the same. So the sugar is being dehydrated while the sulfuric acid is becoming hydrated. And as anybody knows, when you add water to sulfuric acid, or should I say you add sulfuric acid to water, the water heats up to near boiling temperatures because sulfuric acid has a strong affinity for water. It likes to dehydrate things to hydrate itself, and by doing that it creates an exothermic reaction which gives off heat energy. So it naturally will heat up the solution that it's in. So while it's dehydrating the sugar, of course this reaction is heating up. Now I don't have a thermostat or anything to show that happening, but trust me, it is. And as you can see me talking and going on here, watching, more and more of that sugar is becoming black as more of it gets absorbed into the sulfuric acid and becomes dehydrated. And something you might notice over time as you watch the video is you might notice that mass of black carbon that's being formed in there will slowly expand toward the top of the beaker, and then it'll get to a point where it will rapidly expand out of the beaker, and that's your typical carbon pillar that you will get out of the experiment. So anyway, I'm gonna speed up the video here so it can go by a little faster while the dehydration is going on, and you should see that expansion happening in the beaker, and we'll go back to normal speed just before the whole thing. So coming back to regular video speed now, we're at that point where we're just about to have the famous carbon pillar erupt out of the beaker. But as you can see, we're still having some expansion. It's rapidly going to do it right about now. And as you can see, we're starting to see streams of steam come out of it, seeing bubbles show up in the carbon. And the pillar again starts to rise out of it. Now, not all the sugar reacts, because you can see white powdered sugar being pushed out of it. But again, the reaction is so hot that the carbon is kind of in a semi-liquid form right now. And as it continues to rise, more of that steam comes out because of the exothermic reaction. And again, reactions happen faster when they're heated up, so that's why we suddenly get this burst of carbon coming out, because the dehydration has happened much faster now because of the self-heating of the reaction from the sulfuric acid dehydrating the sugar beforehand. So now it just accelerated it. So again, we get carbon as the resulting end product along with water vapor because the heat is burning off the water. but we're also getting sulfur dioxide out of the reaction, and that's the toxic gas that was being mentioned in the warning at the beginning of the video, which is why this reaction needs to be done outside or in a fume hood. Sulfur dioxide is irritating to the nasal passages and lungs and things like that. And again, sulfur dioxide is a constituent of sulfuric acid, so you don't want to have it in a environment with a lot of moisture, because then you could end up getting little traces of sulfuric acid in the air, and you probably don't want that. So, but anyway, we get this pillar of porous carbon that comes out. Porous refers to all the holes that you see in the carbon pillar here, because that's where gas and liquid have been escaping, as you would have seen bubbling through the carbon as it was expanding. Right now the reaction is pretty much finishing up, and the carbon and the vessel is all cooling down, and the carbon itself is hardening up. In a little while I'll just be poking it with a stir rod just to check the carbon itself and things like that. I don't want to handle it with my bare hands because I don't know if there's going to be any remnant sulfuric acid that may be on the carbon or anything like that, because again, if you look at the bottom of the beaker, sulfuric acid is still present, so I don't know how much of that is still going to remain on the carbon itself, which again, the reason you need to wear gloves, because again, you're handling corrosive elements. Anyway, that's pretty much what the classic carbon pillar experiment is with the dehydration of sucrose. So like I say, in the rest of the video, you'll just see me poking around with carbon, and I'll leave the regular audio on just to hear what's going on in the background. But that's pretty much the experiment.